Welcome to this video all about quadratic equations. So we want to plot a quadratic. Quadratic takes the form y is equal to a x squared plus bx plus c. Like with any graph, the point at which it crosses the y-axis, which is when x is equal to 0, will be this value c. Okay, so that's the first thing to remember. The second thing is, when a is positive, we get a U shape. When a is negative, we get an N shape. Okay, so those are two things out of the way. Next thing we might want to know is, what's the minimum? So we can do something called completing the square. We'll do this in the general case. So y is equal to a, and we'll take out a from the first two terms. So we're going to get a x squared plus b over a x plus c, leave that alone. Now we're going to do something to this in the brackets. We're going to in square brackets write x, and then we're going to halve this coefficient plus b over 2a squared, and now you can see squaring this gives us x squared plus bax, but then it also gives us a plus b squared over 4a squared, which is not in this original equation, so we have to subtract that off so that this remains true. So minus, that's not what I meant to put, minus b squared over 4a squared. Okay, then we have our plus c. We multiply the a back in, so we get a x plus b over 2a and minus, well, this is b squared over 4a times by a, so that's b squared over 4a, and we still have our plus c. If we're looking at the turning point of this graph, the minimum or the maximum, well, when a is positive, we get a U shape, so we're looking for a minimum, and that minimum value, since this x plus b over 2a is squared is always positive, the smallest value that can take is 0, so we get the minimum at x is equal to minus b over 2a. Okay, and then when that's the case, our y coordinate is equal to c minus b squared over 4a. This makes more sense when you do it with individual examples, but hopefully you're understanding what I'm trying to get across. When a is negative, we're looking for a maximum because we have this N-shaped quadratic, and since a is negative, we're looking for, again, when this is the smallest, because when this is big or large or has a value, when it's getting multiplied by negative a, that's going to make our value of y smaller. So we want, again, when this is 0, so our turning point again is at x is equal to minus b over 2a, and this will be our maximum. Alright. The next thing I want to look at with quadratics is the discriminant, and the discriminant is equal to b squared minus 4ac. Right, when b squared minus 4ac is greater, that we'll consider the equal to case in a minute, is greater than 0, this implies we have two real roots. So this means we cross the x-axis twice, okay, at unique points. When b squared minus 4ac is equal to 0, we have one repeated root, and this just means we'll just touch the x-axis, but we won't pass through. And the reason we say repeated is because when we put it into the quadratic formula, we're plus or minus in 0, so we get that same root come out twice. Alright, and b squared minus 4ac is less than 0. We have no real roots. So this means the quadratic does not cross the x-axis, so that helps us to draw them. And as I mentioned the quadratic formula, but the reason this is true is because in the quadratic formula, the values of x that give us a y value of 0, which is when we cross the x-axis, are equal to minus b plus or minus the square root of b squared minus 4ac over 2a. And the discriminant is this part here. And now you can see why we get our results that we get, because this is under the square root. When this is positive, you get 2 square roots, the positive and the negative one. Alright, when this is 0, well, the positive and negative square root of 0 is 0, so they're identical. And when this is negative, you don't get any real solutions to the square root, so you don't get any real solutions to the whole equation. Alright, hopefully that's everything covered on quadratics. If you do have a question about them, please let me know in the comments down below as always. For now, please like, subscribe, and I hope to see you in the next one.